Databases have a difficult problem. Thousands of transactions may be reading and writing the same data at the same time. If every read waited for every write to finish, concurrency would collapse. If every write waited for every read, performance would be terrible. The traditional solution was locking. A transaction would lock a row before modifying it, and other transactions might have to wait. While this guarantees correctness, it also creates contention and reduces throughput. Multi-version concurrency control solves this by changing a fundamental assumption. Instead of modifying rows in place, the database creates new versions of rows. When a transaction updates a record, the old version doesn't immediately disappear. Both versions coexist for some period of time. Every transaction is assigned a transaction identifier and sees a consistent snapshot of the database. When a query reads a row, the database determines which version of that row is visible to the transaction based on when the transaction started and which updates had already been committed. This means two transactions can read different versions of the same row at the same time. An older transaction may still see the previous version, while a newer transaction sees the updated one. Neither transaction blocks the other, because each is reading from its own snapshot. Of course, old versions can't live forever. Eventually, no active transaction needs them anymore. At that point, the database performs garbage collection. PostgreSQL uses a process called vacuum, while other databases have their own cleanup mechanisms to reclaim storage occupied by obsolete row versions. Multi-version concurrency control doesn't eliminate all locking. Databases still need locks for certain operations, like schema changes or preventing conflicting writes. But for ordinary reads and writes, the versioning approach dramatically reduces contention. The brilliance of multi-version concurrency control is that it trades extra storage and cleanup work for far better concurrency. By keeping multiple versions of data alive simultaneously, modern databases allow readers and writers to operate largely independently, which is one of the reasons systems like PostgreSQL and InnoDB can support thousands of concurrent transactions efficiently.